Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 9, 2025, about 5 days ago. The standout result is a new reward design that cuts generated tokens by 37.8% to 59.4%, while keeping accuracy essentially intact, with an average decline of 0.9%. The paper is titled, PEAR, Phase Entropy Aware Reward for Efficient Reasoning. And as we will see, the implications for controlling reasoning length are quite significant. This paper links phase-specific entropy to response length and delivers adaptive, out-of-distribution, robust compression without rigid length targets. Also, the authors shared an official GitHub repo. You'll find the PEAR reward implementation in Python, a quick start example using compute score, and step-by-step integration with the VRL framework. It includes GSM 8K setup notes, training configuration guidance, and scripts to replace the reward manager and init hooks for entropy-aware scoring. Alright, Figure 1 shows how PEAR shortens reasoning by managing entropy across two phases. Entropy here means how uncertain the model is about the next token, which signals exploration versus commitment. The left red thinking zone is discouraged, so the model explores less and trims redundant steps. The right blue answer zone is allowed moderate entropy, so the model can still adjust wording while committing to the solution. The lower row illustrates the mechanism that reduces thinking entropy and preserves accuracy without manual length targets. Well, Figure 1 showed why steering entropy by phase can shorten reasoning without hurting accuracy. Figure 2 shows that higher average entropy goes with longer responses, which means more exploratory token choices tend to inflate length. On the left scatter plot, points climb with tokens, and larger dots hint at solid accuracy. On the right bar chart, the thinking bars sit notably higher than the final answer bars, so uncertainty concentrates before the solution. So Figure 2 laid out the entropy length link. Table 1 reports accuracy in generated tokens across 4 math benchmarks for 3 model sizes. The headline is simple. PEAR uses far fewer tokens while keeping accuracy comparable. The smallest model trims about 38%. The 4 and 8 billion models drop roughly 59%, which supports the idea that larger models over-explain. Competing methods shorten outputs but pay a bigger accuracy cost. Okay, Table 1 reported big token savings with minimal accuracy loss. Figure 4 shows why that happens, because entropy drops mainly during the thinking phase, while the final answer keeps small flexibility. The left panel charts that shift across model sizes, highlighting a clear reduction in uncertainty during thinking. The right panel shows that QN34B takes fewer reasoning steps and uses fewer tokens per step, so the traces shrink without hurting solution quality. Alright, 2 takeaways stand out. Phase-dependent entropy is a clean control knob for reasoning length, and the PEAR reward trims about 38 to 59% of tokens with roughly 1% accuracy cost. The broader implication is practical. Reward shaping can deliver concise, robust reasoning without length rules, lowering deployment cost. Thanks for listening. This is Alex, signing off from AI Research Roundup.